Young people, welcome back. Glad to see you. BNB, here to help you out. See what we got, guys. Brand new chapter, brand new lesson. Chapter 7, lesson 1, guys. The learning objective for the multiplication properties of exponents is multiply monomials using the properties of exponents. The second objective, simplify exponents using the multiplication properties of exponents. All right, guys. So we're gonna go ahead and get this thing started. We got some fresh new music. I love it. I love it. Hey, took a lot to get my editor, man. He didn't want it. You can thank me for that, y'all. Put some comments in there, guys. What would you like to hear? On that, let's get to this nice, easy lesson of multiplying exponents. Get it going. All right. Well, actually, I'm gonna. Now we're going. All right, there it is, guys. And there it goes. So, look like a full handout. And of course, it's always gonna have our title in there. And our directions looks like to determine whether each expression is a monomial. All right, monomial meaning one, so just one term. Terms are separated by addition or subtraction. So 11, which is a constant, is a term, is a monomial, one term. Number 2, a minus b is no because there's subtraction between them. A is a term and b is a term. So there's actually two terms. We call it a binomial, right? So monomial, one term, binomial, two terms, trinomial, three. Number 3 is actually yes. Even though you see something in the top, something in the bottom, since they're being divided, it's just kind of like multiplication. Just like 2y would be yes, 2 divided by x would be yes. So all the rest are yes except for the last one because you see again as addition. Addition and subtraction separate terms. So there's no addition or subtraction in any others except for number 2 and number 6. So that's me explaining it. And I like how I explained it. I hope you did too. And I guess I can go into more detail. Detail for number 5 is you're just multiplying. Multiplication does not separate terms. That's why you can have 2x, x times y, right? I guess that's enough explaining. I'm happy with that. Get that stuff out of here. Let's get some real work in here. Simplify. In other words, do the problem. So it looks like the first one's got a squared times a cubed times a to the 6th. So they're all a's, and how many total a's do I have? I can write it out, meaning a times a times a times a, and then a times a. No, I'm using the rule. And when multiplying exponents, we add them. So 2 plus 3 plus 6 is 11. There's 11 a's there. For the next one, I've got 2 different variables this time. And y to the second, z, that's the first term, times the second term, yz squared. And the only reason I say that, guys, is they have them in parentheses. But when you multiply, it's going to give you one single term. But let's keep it together. Meaning y squared times y, or in other words, y squared plus 1, because you get the, and that can sound confusing, but you're going to see how I write it, just as I wrote it above. The exponents is what we're adding. So there it is, y to the power of 2 plus 1, and then z to the power of 1 plus 2. So you can see I'm using the exponent rules, showing the operation of addition when I'm multiplying exponents. Here we go. Again, 2 sets of parentheses, so I got a's and b's, so a to the 4th power, b to the 8th power. I added 2 plus 2 and 4 plus 4. For 13, this has my first set of coefficients. So 2x squared times 3x to the 5th. I can multiply the values I know. I know what 2 times 3 is. It's 6. I don't know what x squared times x to the 5th is because I don't know what x is, so I can just rewrite it as a single variable of x, single exponent as x to the 7th. Yeah. And here we go, guys, for this last one here. And it looks like it's got a little bit more going on. So 4xy cubed times the quantity 3x cubed y to the fifth. So again, there's 4 times 3, which I can do. I know what 4 times 3 is. Then I got 1x in the first one and 3x's in the third one. 1 and 3 give me 4. 3y's in the first one and 5 in the second. 3 plus 5 gives me 8. So, boom, pow, look at what we got. And that's it, guys. Really nothing more than adding. You know, it's going to get more complicated, of course. But for right now, guys, straightforward, straight into it. Let's keep this party going. And here comes the party. All right, definitely, guys. If you notice, I'm jumping around the handout. I don't always do all of the questions, but I do want to make sure that I do enough that you leave with an understanding. So, first one, 7a to the fifth, b to the second, times a to the second, b to the third. So I have coefficients, but just one, so I just leave my 7. But how many a's all together? Again, the rule is to add. So I'm going to put 5 plus 2. 7a to the power of 5 plus 2. b to the power of 2 plus 3. So your final answer, 7a to the 7th, b to the 5th. Nothing else to do. All right? Knowing that you're done is half of the job, guys. You'll be like, is that it? Yeah. There's nothing else to do. That's a simplified answer, right? So here, guys, throwing some negatives in to make sure it's not your Achilles heel. 2 times 4, or in this case, negative 2 times negative 4. And again, I'm writing it to show how you can show your work and expanding out your expression. So, or rewriting the expression to rewriting the problem, however you want to phrase it. But c to the 4th times c, all right, times d. This time I just put what I know. How many total c's now? Looks like I'm going to have 5 c's and 2 d's, but not forgetting the coefficient of 8, c to the 5th, b to the 2nd. Give me a box and let's keep it going. Next one, guys, we're switching up our rules, but I can use the same. You don't add here, guys, because they're taking a power to a power. And what I mean by p to the 3rd all to the 12th power, there's actually 12 parentheses now. And p to the 3rd is inside of all of them. So now, that would mean to multiply. P to the 36th power. Right. So, I'm going to actually take an opportunity to pause right before 22. So guys, the reason I'm pausing is you've seen me pull in graphic organizers. You've seen me pull in, what would it be? Definitions to vocabulary. You've seen me pull in key concepts from the textbook, right? So I did not start this video with your exponent rules. So when multiplying exponents, we add. When dividing exponents, we subtract. When taking the power of a power, we multiply our exponents. So that's it. If I was going to YouTube right now, guys, YouTube, that's what I didn't say that. If I were to go to Google or a search engine and I put in exponent rules, it 1.7 million results, right? So I'm saying that to say, make sure you got it in your notes. Make sure you know those rules. There's just 3 of them. And let's make sure you got it before you finish this handout. Let's get back to it. In 22, I see something similar, right? I see that there's a power of a power. The invisible power of 1. So negative 3 to the first power, so 1 times 3. And then y to the first power, 1 times 3. So literally, you take that exponent, 3 outside the parentheses, and give it to the negative 3, and you give it to the 1. And that's it, guys. I did multiply, but I'm showing again, and this is what I didn't do in 20. In 20, I did not show 12 sets of parentheses, right? But if the exponent is touching the parentheses, that means that's what you're going to multiply by itself, whatever's inside the parentheses. So here, 3 isn't that bad. Negative 3 times negative 3 times negative 3 gives me negative 27. Y times y times y. Of course, y to the 3rd. So, same thing going on here. And when I say same thing, it has a 2 for the exponent of the parentheses. Of the parentheses. So parentheses times parentheses, right? And whatever's inside is what I write. So now I can see that it's easily a 2 times 2, right? Because that's the coefficient. And then I can easily see that it's b to the third times b to the third. So that's 6 b's. C to the fourth times c to the fourth. So there's 8 c's, right? So again, counting, adding, even multiplying, because 2 times 3 would be that 6. 2 times 4 would be that 8, so I didn't have to expand it out. But I did. And I like it. So, let's get the next set in here, guys. And it looks like we're going back to some of the more, I don't want to say easier, but different skill, right? Here we're multiplying exponents, so not taking the power of an exponent. Just counting my x's. Looks like 9 plus 1. X to the 10th power. And of course, for number 10, what I may do with one of my students or somebody in class is, and there you go guys, showing the rule again, right? Make sure you understand why I ended up putting 10. Just writing it as a rule, x to the, and then show what you're adding. But for 10 guys, what is cool about 10 is you can write it out. How many total L's do I have? On the first parentheses, I got 2. In the second parentheses, I got 3. How many total L's is that? 5 L's, right? But what about K? How many total K's are in this? Well, 2 in the first, plus 1 in the second. 2 plus 1 is 3. You notice how in 8 I showed it, but in 10, I'm writing it out. L times L, and of course, times K times K. And of course, L times L times L times K, which is why I have 5 L's and 3 K's, L to the 5th, K to the 3rd. Same thing, guys, here for 12 now. Excuse me. Parentheses, CD to the second power, parentheses close. Parentheses open, C to the third, D to the second, parentheses close. Meaning, C to the 1 plus 3 power, D to the 2 plus 2 power, 1 plus 3 is 4, and of course 2 plus 2 is 4. So C to the 4th, D to the 4th. And again, we finally got some coefficients. So do I know what 5 times 4 is? Of course. And if I got 7 A's, then I'm going to multiply that by another 2 A's. Well, I don't know what A is, so I'm just going to say I got a whole lot of A's. I'm a smart guy. Did you get that whole lot of A's? Smart guy, 4.3? All right, whatever. I thought it was good. I'm going to have my editor put like some, I know it was funny. All right, guys, here we go. So, getting in, look at it. There we go, some power of power again. 17, negative 5m cubed. All right, and 3m to the 8. So, negative 5 and 3, easy enough, guys. We're going to get a negative 15. But how many total m's are we looking at again? Well, 3 m's in the first parentheses, 8 m's in the second. And of course, nothing but adding, right? So I'm not going to put m times m times m times m times m times m. I'm just going to put m to the 3 plus 8 power. And there it is, guys, negative 15, m to the 11. So now on 19, this is the power of a power. I got 10 to the second, all to the third power. Let me say it again. 10 to the second, all to the third power. All right, so I would have 10 to the second times 10 to the second times 10 to the second times 10 to the second. Or just, what do you know? 10 to the second is 100. All right? Well, 10 to the second times 10 to the second times 10 to the second. Or 100 times 100 times 100. Whichever way your brain wants you to calculate this, guys. But to me, I'm going to use the rule. What's 2 times 3? Bam. 6. You got it, right? So this is actually one where I can give a simplified answer, and what I mean by that, I don't need the exponent because I can tell you what 10 to the 6th power is. Just get a bunch of zeros and you are a millionaire. Yes, you are. So, again, guys, showing the rule with 19, the same way I showed the rule with 17. You notice in 19 it says 2 times 3 because it's the power of power. And then, of course, in 17 it's addition. Go ahead and show in 21. You can distribute, you know that word from other lessons. Distribute your power to your coefficient and to your variable. I'm basically multiplying the invisible 1 times 2 for -6 and for p. Now, check it out for 23. 23, 3 to what power? The first power. So 1 times 2 give me 3 to the second. P to the invisible 1 power. Again, 2 times 1 gave me 2. But r to the second power. Right. R to the second power. Well, that's r to the fourth now. So 3 squared give me 9. P to the second. R to the fourth. And there's our box answer, guys. All right. So, feeling good, looking good. Let's get this stuff out of here. We are definitely going to get to the bottom portion of the handout, which is applying this to more natural occurrences, meaning you got to cover your yard, you got to do something right, you got to find that area, you got some unknown values. So here it is for 25. The area is basically the base times the height. So x to the fifth times x to the second. Well, it's like 5 plus 2, x to the seventh. The next one is a square, and again, to me, that's base times height again. Or in other words, side squared, depending on the teacher and the textbook or how you got that formula. But again, the area here is just going to be base times height, and I guess I just want to say, what am I choosing here? Parentheses times parentheses. I don't want to put b, because you don't even need that. But CD times CD, 2 C's and 2 D's, so CD to the second, and C squared, D squared. We took care of that. Last 127 is real special because if you're not sure, the area of a triangle is 1/2 base times height. So we're going to take the base, which is, and I'll let it catch up, area is equal to 1/2 times 9p to the third power. And then the height right there, guys, is 4p. So, same thing, just adding a fraction in front. So we got to divide everything by half. That's 9 times 4. It's going to give me 36. 3 p's plus 1 more p gives me 4p. And of course, half of that is just half of 36. So 18 p to the 4th. And that's pretty much it, guys. Again, I think that's a great way to start off this chapter. We're going to be dealing with exponents throughout this. We got a few more rules coming around, division and whatnot. Thanks for checking it out, guys. See you in the next video.